This is 3.2, polynomial functions and their graphs. So a polynomial function, we've talked about that even in Algebra 1, Algebra 2, but this, again, we're going to take it a little bit further, a deeper step into this, a polynomial function of degree n. It looks like this, and this is the generic form. So you need to be familiar, somewhat familiar with what this is talking about. So even if I had, f of x, equals x cubed plus 4x squared minus 3x plus 9. Again, notice that the exponent n, and then n minus 1, and then it keeps counting down, just like I went 3, 2, 1, and then it goes all the way down to, to the a sub 0 here, so in other words, the constant. So that's the generic form of a polynomial. So the a sub 1, a sub 0, they're called coefficients, just so you're familiar with the terminology. And of course, the last term is called the constant. And of course, we have a leading term as well, the very first term. So in this case, the leading term is a 1. And then, we're talking about of the highest power, so x cubed. If you put them in descending order, then you can see the leading term. So we often refer to polynomial functions just as polynomials. We just kind of, as math people, we just kind of call it that, and we just know we're talking about a function. So here's an example of all the terminology. So here's an example of 3x to the 5th plus 6x to the 4th, and so forth. Notice the coefficients of 3, 6, negative 2, 1, 7, and then negative 6. So in the constant term is the number. Degree is 5, it's the highest exponent. The leading coefficient, again, if you have it in descending order, the leading coefficient, you can see is 3, and the whole leading term is 3x to the 5th. And again, here's some more examples, just to refresh your memory with some of those, with some of the terminology. And just as a refresher, a monomial is a single term. And, of course, we can talk about binomials. So this is a binomial, that's a binomial, that's a trinomial, that's a trinomial. So just refresh your memory on all these definitions. So we've talked about parent functions. And if you notice parent functions, especially, we said this last time, x squared, notice I have this at the very beginning here, x squared, x to the 4th, x to the 6th, x to the 8th, all the even exponents. And then the same thing with the y equals x cubed, x to the 5th, x to the 7th, so all the odd exponents. If you start graphing those, and again, if you just specifically notice, let's look at the x squared, the x to the 4th. So the graphs become flatter around the origin and steeper elsewhere. So if you literally made an XY chart, you can start plugging in numbers to x squared, and then use those same numbers to plug them in x 4th, and you can see that it's becoming flatter around the origin. Now, something I want to emphasize to you, a lot of times we plug in 0, 1, 2, but don't forget about all the numbers in between there, like 0.1, 0.2, 0.3, 0.4. Don't forget all those decimals are in there. So what happens when I plug 0.1 in? What happens when I plug 0.2 in? And the same thing with in between here. We have 1.1, 1.2, and even like 1.01, 1.02, and even 1.001, 1.002. I mean, what happens to the graph when you plug these numbers in? And that's what you can see, the relationships. It becomes flatter around the origin and steeper elsewhere. But they all based on the parent function, y equals x squared. All the even exponents and all the odd exponents are, x is based on the parent function, y equals x cubed. They all look very similar to the parent function. All right. So something that you need to be aware of too is all of these polynomials. Polynomials have to have several different things. Notice here we talked about continuous functions, and we talked about different types of functions, but this polynomial is not like comes to a point. This is not a polynomial function. It's nice. It has a smooth curve. It's continuous. It's not a piecewise function. So this is not a polynomial. And again, you can see this one is nice and smooth and curved. Same thing here. So we got polynomials graphing there. That's something you should recognize on a polynomial. So this is important about domain and range. The domain of a polynomial function, you need to know about what it is. So as x goes towards infinity. So again, imagine a graph as the x line goes 1, 2, 3. What's happening to the polynomial? So as x goes to infinity, that is, x keeps increasing without bounds. So x goes to 4, 5, 6. Keep imagining what happens if x gets to 100, 1,000. What happens to the graph? Same thing here. As x goes this way to -1, to -2, -3, what is happening to the graph? And the end behavior of a polynomial is very important as far as the graphing part of it, because whatever it's talking about, you might have a simple parabola. Notice the endpoints are both going up. So something cubed, notice the endpoints are opposite directions. So again, the parent function is this, and the end behaviors you need to be familiar with. What's happening as, if I graph this function, let's just say the x cubed, if I graph this, as x goes to 2, what's happening to the y function? As x goes to 3, what's happening to the y function? As x goes to 4, what's happening? And so you need to always think about the end behavior. What is, as x goes to 100, as x goes to 1,000, what is happening to the end behavior of that graph? So notice if it's an even, we kind of already said this, if the function is even, as x goes towards infinity, as x goes 1, 2, 3, 4, 5, as x goes towards infinity, notice y is also going toward infinity. As x goes to negative infinity, so as I get further and further and further, notice the y, as x goes to negative infinity, y still goes to positive infinity. So again, on even functions, it has this same, so y equals x squared, y equals x to the 4th, y equals x to the 6th. They all have this same end behavior. And the same thing with if it's this is if a is a positive, by the way, the leading coefficient is positive. If the leading coefficient is negative, so we're talking about y equals negative x squared, y equals negative x to the 4th. So they're still even functions. They're still even functions, but it's being reflected. So notice as x goes to 1, 2, 3, 4, notice the end behavior, x. Notice as x keeps going higher and higher and higher, the y is getting lower, lower, and lower. So y goes towards negative infinity. As x gets negative, more negative, -3, -4, -5, then what's happening to the y values? It's getting more negative. So notice as x goes to negative infinity, y is also going to negative infinity. So notice on an even degree here that we're talking about, the end behaviors are the same. Now on odd functions or odd degrees, notice what's happening here. As x gets bigger, notice as x gets bigger, again, this is the coefficient's positive, then notice the y is getting bigger. As x gets more negative, -3, -4, notice the y gets negative, more negative. It keeps going to higher and higher negative numbers. Notice this is a negative coefficient. This is a negative coefficient. So again, we're talking about something like negative x cubed, something like that, or negative x to the 5th, an odd degree with a negative coefficient. So as x goes to 1, 2, 3, notice the y values go to negative infinity. As x goes to -1, -2, -3, notice the y values go positive, higher and higher in value. So you need to be familiar with how to graph it and the end behaviors of an even function and an odd function. So if I had something like this, determine the end behavior of a polynomial. So here's an example. So notice the polynomial p has degree 4. So notice degree 4, and that means the end behaviors are going to be the same. Remember, the parent function is this. So they're both going to be going, degree 4, they're both going to be going the same direction. But notice the leading coefficient's -2. So the parabola is, well, I shouldn't say it's parabola, but the degree is going to be going down. The in behaviors are both going down. So it has an even degree, negative leading coefficient. So I know the in behaviors will literally be going like this. Now it could be doing whatever's in between, it could be going like this, something like that. But the in behavior is what we're looking at, the in behavior, this guy and this guy. Because it's to the fourth power, we know they're both going the same direction. So let's talk about using zeros to graph the polynomial. We've already talked about this, finding the zeros. Remember, we're talking about zeros, whatever the function is, whatever this is, we're looking at zeros. Zeros are where it hits the x line at. That's what we're talking about. So to find the zero, what we're going to do is factor it or use the quadratic formula, and we're going to basically find those zeros, and that's going to help us graph the function. So once we know x equals c, once we know the zeros, once we factor it, then x minus c is the actual factor. So in other words, if x equals 2, we know that's a 0, then I know x minus 2 is a factor. Likewise, if we factored something x minus 2 and x plus 3, then we know that this is negative 3 as a 0, and we know this is positive 2 as a 0. So that's really what it's talking about. And again, zeros are called x-intercepts. So as an example, here we have a polynomial. If we factored this, we have this, and we can see that negative 3 is a 0, and we see that positive 2 is a 0. Now, something I want you to point out, I want to point out to you, notice it's x squared. Notice it's a positive. So we know that it's a parabola because it's x squared and it's positive. So we know the parabola is going to go up. So because we know these two are zeros, we know in general the graph will look like this. Okay. Now we can find the vertex. We can graph it more accurately. But I want you to just basically look at the graph, and in general, notice the in behaviors. The in behaviors are both going up, and we know this because of the zeros that we found, the x-intercepts, and we know that the parabola is positive, so that we know that the parabola is going up. We know the zeros are there. I also want to point out, in general, we know this. Okay, in general, we know this. So we know negative 3 is there, and we know x is 2. But notice if I started plugging x's in, so just think of the xy chart. So I know at 2 it's 0. And so what happens if I plug in 3, or 2.1? What is happening as I go a little bit bigger, as I go a little bit bigger, as I go a little bit bigger, whatever number I plug in, 3.3, 3.9, 4.5, as I get bigger, notice what's happening to that function. It's increasing this way. Notice as I go a little lower than that, so if I start plugging in numbers like negative, or 1.5, I start plugging in 1.5, 1.4, if I start plugging in numbers, notice what's happening to the graph. It's going below the x line. So notice at the 0, notice it switches. Just something I want you to pay attention to. Notice it kind of switches from positive values to negative values, the y does. So think of this point. This point has a positive y value, and this point down here has a negative y value. And again, it comes down to the vertex, and as x goes closer and closer to this point, it's going higher and higher and higher. It hits x equals 0 right here, and again, this is negative 3, 0. And once I start plugging in numbers over here, then it starts going above the y value, it starts going positive. So as x gets more negative, negative 6, negative 7, negative 8, negative 10, as x goes towards negative infinity, notice the y value is going toward infinity. And the same thing here, as x goes more and more, as x goes towards infinity, the y value goes towards positive infinity as well. So notice the in behaviors. We often focus on just the normal numbers, 2, 3, 4, but again, notice the in behaviors and all the characteristics that's happening in between those zeros as well. This is part 1 of this lesson video. Be sure you watch part 2.